I wanted to give you an update on what I'm doing here. I kind of got this together. I just put it together. It's just a preliminary, but this is what I was kind of thinking of. Now, this being the front, this being the back. I got the axles in there. It pivots. So this is what it looked like when it's straight up and down. And when it's all the way forward, it would be like this. Now this piece here goes all underneath this piece. It rides in this track. And there's going to be a belt in there. That's what's going to make this move. The motor is inside this unit. It's in the back, right over here. That's going to make this rotate. Then this motor that goes in here is going to make it rotate this way. Now I got this, remember this ring I made to make sure that I get that to rotate with that motor in there. And I got it to work. So this ring is going to be replaced with this aluminum piece. That's going to fit in there. And then the plate is going to be put on top. Now originally I was going to put this plate on top, but it's too big. See, it's going to hit this piece back here when it rotates up. So I'm going to probably end up with a round piece. It's going to fit on top of here and mount my dovetail clamp, whether I use a vise or some kind of dovetail vise or something. I'm not quite got that far yet. But I ran into a little issue when I put this together. So this bar I got going across here, you'll see this channel is 2-inch square tubing. So this goes down to the bottom of that channel. So that means it's 2 inches from the top. Now the center point, the rotation point of this unit is in the center of this 2-inch channel. So that means that the center point is 1 inch from the top, and this bar is 2 inches from the top. So what happens is that when this gets rotated, (90 degrees), at the center here is 1 inch above this piece of angle and 1 inch above the top of here. So if I had a piece that was bigger than 2-inch diameter, I couldn't run it. See, if I had, this is that vise I was working on. Let's say I had that vise in here, sitting on the plate. And let's say I was doing some work to that. Now if I flip that up like that, that just barely clears, because that's not, did you see what I'm saying here? So that would hit that. See it hitting there? So that's not going to work. So I'm going to have to move this somehow. I got to figure that out. But I didn't foresee that until I put this together, and now it's really visible once you have this together, and you can see it. But we'll get it figured out. Yeah, I have to have this piece because that's where the belt drives this unit. Now if I didn't have this piece, I would have to drive this unit from the side or from the axle or from somewhere, but I really didn't want to do that. I really want to drive it from the center, because this is where the pulley system comes out to drive that belt. This is underneath, and I really wanted to use that. But we'll get it figured out. We didn't come this far to stop. So we got to incorporate the teeth into this unit so I can put it on top of here. And then mount the plate on top of that. This is a piece of tubing. This was, what was that? 6.5 inch by 5 inch. Yeah, that was quite a piece. Yeah, 6.5 inch by 5 inch. And this thing was, I don't know, what was it, like 3 foot long, and I cut off a piece. And I put an undercut in it. Because that's gotta fit in there. And I got a little piston that goes in here to clamp on this part. Then of course the teeth are going to go inside to attach to that belt so it can rotate. But I got the gear for the adapter for the gear finished. That's tight. This is going to mount on the motor. Little set screw goes in here. I got a little keyway that's going to go in here. The keyway goes into here. This is the key. That's what I had that reamer for. Bore that out. Well, ream it out for the shaft of the motor. And I just put the key right through onto the shaft. The shaft is going to hold it up. The thickness was so thin here that I had to go through with the key because I needed that room so the shaft will stop it from falling through. But that's that piece I made that was, I don't know, it was like 4 inches long or something, and I cut it out and I turned it and I reamed it, faced it, drilled that hole. Yeah, it's a little snug. It's supposed to be snug. Yeah, it's not going anywhere. That's not going to fall out. So I got the parts I ordered. I got the little hand wheel part. I got the motor driver. And I got the, this little part fits on top of the motor driver. And the heat sink came off of the part. It's supposed to be glued on there, and it fell off. I guess during shipping or something, I don't know. But I have to glue it back on. The little heat sink fell off. It's not a big deal. And what else did I do? Oh, I got some wire. Ordered some wire. Ribbon cable. But the main thing was that, I had to get that gear working before, and I got that to rotate. So now I'm able to continue on with this. But oh yeah, originally I had these on there. Now these are the little yoke brackets that I had on the side here. So I got these plates replacing this piece because what was happening was that where these holes are, that's the top of this surface here, and that's the center line of the axis. So I had it bolted here where the axis, this was where the axis was, and this is the top of this piece right here. So what it did was it lowered this whole unit by I think it was 1 3/8 or 2 3/8 or yeah, 2 3/8. So it lowered this pivoting unit by 2 3/8, which wasn't a big deal for, for cutting stuff on top. But what was happening was that this bracket that I have to drive the belt, it had to be on the same radius as this axis right here, where the center of this is. The axis that runs through here, which was the top of this surface, is now 2 3/8 below the top of this surface. So this surface is lowered, so the axis made it swing a different arc, a bigger arc. So I would have had to make this piece here, the arc of this piece, a lot bigger. See, this piece right here would have had to been a lot bigger, because the arc of this rotating is now like a pendulum, and it was swinging back and forth, and it was too big. I would have had to extend this bracket way out here, and this bracket would have came way out here, and I mean, I could have made it work, but I didn't want to go through all that right now. I just wanted to keep it simple. So this actually was the original plan that I had, but I thought, well, I'll swing that down, and that way, I can put taller things on it, because I planned on using, this vise and this and that, but then after you think about it for a while, you say, well, let me keep it simple right now, and just get it working, and then we can go and try different things once we get it going. So that's what we're going to do. We're going to go with the simpler plan right now. Make sure this thing's working, and then we can always, readjust it later on for specific items that are longer, but we'll just we'll get it going first. Well, it's looking pretty good. I put cutouts on here for wrenches. That's the nut. And there's a piece here. The axle has a cutout. And the nut has a cutout. Now that cutout, I thought, well, I'm going to have to make a wrench for that, because, it's really narrow. It's only, a 1/4 inch wide. I used a 1/4 inch end mill, just put a cut in it. And then I looked at that ER32 wrench, and that's got a nice big thickness on it, and it was only 230 thousandths wide. So I said, well, that'll work. I just use a standard ER wrench, and I can tighten that up or loosen it. And I think it was like 3/4 diameter, or somewhere around there, some kind of metric size, I'm sure. But I said, yeah, that'll work, and that worked out really good. I was able to make that. Didn't have to make a wrench for it. Just off the shelf item. So between the wrench that I had and the wrench we have in the shop, I got 2 wrenches. Just what I need to tighten that up. But yeah, that's where we are now. All right. Talk to you later.